Session in Hibernate. Now we are focusing on session, the main runtime interface between Java application and Hibernate. This is the central API class abstracting the notion of a persistence service. The lifecycle of a session is bounded by the beginning and end of a logical transaction. Long transactions might span several database transactions. The main function of the session is to offer create, read, and delete operations for instances of mapped entity classes. Instances may exist in one of three states: transient, never persistent, not associated with any session; persistent, associated with a unique session; detached, previously persistent and not associated with any session. Transient instances may be made persistent by calling save, persist, and or save or update. Persistent instances may be made transient by calling delete. Any instance returned by a get or load method is persistent. Detached instances may be made persistent by calling update, save or update, locked, or replicate. The state of a transient or detached instance may also be made persistent as a new persistent instance by calling merge, save, and persist methods result in an SQL insert, delete method in SQL delete, and update method or merge method in an SQL update. Changes to persistent instances are detached at flush time and also result in an SQL update. Save or update method and replicate method result in either an insert or an update. It is not intended that implementers be thread safe. Instead, each thread transaction should obtain its own instance from a session factory. A session instance is serializable if its persistent classes are serializable. If the session throws an exception, the transaction must be rolled back and the session discarded. The internal state of the session might not be consistent with the database after the exception occurs. Here you can see session methods that make state transitions happen. An entity instance in our application appears in one of three main states in relation to the session persistence context. Transient. This transient isn't and never was attached to a session. This instance has no corresponding rows in the database. It's usually just a new object that we created to save to the database. Persistent. This instance is associated with a unique session object. Upon flushing the session to the database, this entity is guaranteed to have corresponding consistent record in the database. Detached. This instance was once attached to a session in a persistent state, but now it's not. An instance entered this state. If we evict it from context, clear or close the session, or put the instance through serialization, deserialization process. When the entity instance is in the persistent state, all the changes that we make to the mapped fields of this instance will be applied to the corresponding database records and fields upon flushing session. The persistent instance is online, whereas the detached instance is offline and not monitored for changes. This means that when we change the fields of a persistent object, we don't have to call save, update, or any of those methods to get these changes to the database. All we need to do is commit the transaction, flush the transaction, or close the session. Persist. The persist method is intended to add a new entity instant to the persistent context. That is transitioning an instance from transient to persistent state. Save. The save method is an original Hibernate method that doesn't conform to the JPA specification. Its purpose is basically the same as persist, but it has different implementation details. The documentation for this method strictly states that it persists the instant, first assigning a generated identifier the method will return serializable value of this identifier. Merge. The main intention of the merge method is to update a persistent entity instance with new field values from the detached entity instance. For instance, suppose we have RESTful interface with the method of retrieving a JSON serialized object by its ID to the caller, and the method that receives an update version of this object from the caller. An entity that passed through such serialization, deserialization will appear in a detached state. After deserializing this entity instance, we need to get a persistent entity instance from a persistent context and update its field with new values from this detached instance. So the merge method does exactly that. Find an entity instance by ID taken from past object. Either an existing entity instance from the persistent context is retrieved, or a new instance loaded from database. Copies fields from the past object to the instance. Returns a newly updated instance. Update. As with persist and save the update method is an original Hibernate method. Its semantics differ in several key points. It acts upon a past object. Its return type is void. The update method transitions the past object from detached to persistent state. This method throws an exception if the pass is in if we pass it a transient entity. Save or update. This method appears only in Hibernate API and doesn't have its standardized counterpart similar to update. We can also use it for reattaching instances. Actually, the internal default update event listener class that processes the update method is a class of default save or update listener, just overriding some functionality. The main difference of the save or update method is that it doesn't throw an exception when we apply it to a transition instance. Instead, it makes it transient instance persistent. Here you can see a new is passed to transient, and transient interacts with persistent. Save persistent. Save persist. Save updates are from transient to persistent. Delete is from persistent to transient. Persistent object is inside in the session. Persistent interacts with detach, evict, and session.close are passed from persistent to detach. Locked update, merge, and save or update are passed from detach to persistent. Get, load, and SQL query are to persistent. We can consider this code segment as an example. Session factory in Hibernate 5 example here, and a local session factory bin is created here, and here you can see a interface session. The main runtime interface between a Java application and Hibernate. This is the central API class abstracting the notion of a persistent service, and this is in org.hibernate package. Here we can consider this segment in hibernate.cfg.xml file. Here you can see set the current session context here, and you can see the property hibernate.current session context class here. Supply a custom strategy for scoping of the current session. Example JTA thread managed custom.class. Now we are considering interface session. The main runtime interface between a Java application and Hibernate represents the notion of a persistent context, a set of managed entity instances associated with the logical transaction. This is in the package org.hibernate. Now we are considering session.lock method in locking. This is a session.lock example. The void lock object and lock options. Obtain a lock on a given managed instance associated with this session using the given lock options. This is in the interface session and which is in the package work.hibernate. The following example shows how to obtain a shared database locked. Now we are considering session batching. In batching, here is a naive way to insert 100,000 entities with Hibernate. The following example shows an anti-pattern for batch inserts. There are several problems associated with this example. 1. Hibernate caches all newly created customer instances in the session level cache. So when the transaction ends, 100,000 entities are managed by the persistent context. If the maximum memory is allocated to the JVM is rather low, in this example could fail with an out of memory exception. The Java 1.8 JVM allocated either quarter of the available RAM or 1 GB, which can easily accommodate 100,000 objects in the heap. 2. Long-running transactions can deplete a connection pool, so rather transactions don't get a chance to proceed. 3. JDBC batching is not enabled by default, so every insert statement requires a database round trip. To enable JDBC batching, set the hibernate.jdbc.batch_size property to an integer between 10 and 50. Hibernate disables insert batching at the JDBC level transparently if you use the identifier generator. Now we are considering batch insert, flushing and clearing session. Clearing the session. The method void flush force this session to flush must be called at the end of the unit of work before the transaction is committed. Depending on the current flush mode, the session might automatically flush when entity transaction.commit is called, and it is not necessary to call this method directly. Void clear method completely clear the session, evict all loaded instances and cancel all pending saves, updates and deletions. Do not close open iterators or instances of scrollable results. We are discussing about the flush method and clear methods in interface session, which is in the package work.hibernate. When you make new object persistent, employ methods flush and clear to the session regularly to control the size of the first level cache. Here you can see flushing and clearing session. Flush the batch of inserts and release memory. Now we are considering session scroll using scroll method. The method scrollable result are scroll mod returns scrollable access to the query results. The capabilities of return scrollable results depending on the specified scroll mode. This is in the interface selection query R, which is in the package org.hibernate.query. When you retrieve and update data, flush and clear the session regularly. In addition, use method scroll to take advantage of server-side cursors for queries and that returns many rows of data. If left unclosed by the application, the Hibernate will automatically close the underlying resources, for example, result set and prepared statement used internally by scrollable result. When the transaction is ended, either commit or roll back. However, it is good practice to close scrollable results explicitly. Flush the batch updates and release the memory. Here now we are considering stateless session. Using a stateless session interface stateless session, a command-oriented API often used for performing bulk operations against the database. A stateless session has no persistent context and always works directly with detached entity instance. Thus, when a method of interface is called, by necessarily interaction with the database happens immediately and synchronously. This is in the package Hibernate, org.hibernate. The stateless session is an alternative session and provides a command-oriented API with no associated persistence context. Thus, a stateless session is slightly lower level abstraction that is closer to the underlying JDBC activity. There is no first level cache. The stateless session does not interact with any second level or query cache. There is no transactional write behind automatic dirty checking. Instead, persistent operations occur synchronously when a method of stateless session is invoked. The entities returned by the stateless sessions are always detached. A stateless session may be used to stream data to and from the database in the form of detached object. With the stateless session, there is no need to explicitly manage the size of the first level cache by explicitly clearing the persistent context. The stateless session API comes with certain limitations. Operations performed using a stateless session never cascade to associated instances. Collections are ignored by a stateless session. Lazy loading of associations is not transparent and only available via an explicit operation named fetch. And operations performed via a stateless session bypass Hibernate's event model and interceptors. Due to the lack of first level cache, stateless sessions are vulnerable to data aliasing effects. Here using stateless session. The customer instances returned by the query are immediately detached. They are never associated with any persistence context. The insert method, update method, and delete operations defined by the stateless session interface operate directly on database rows. They cause corresponding SQL operations to be executed immediately. They have different semantics from the save or update, and delete operations defined by session interface. Here the interface stateless session, a command-oriented API often used for performing bulk operation against the database. A stateless session has no persistence context and always work directly with detached entity instances. When a method of this interface is called, any necessary interaction with the database happens immediately and synchronously. This is in the package org.hibernate. Now we are considering multi-tenancy Hibernate session configuration in multi-tenancy in Hibernate in multi-tenancy. The Hibernate session can be configured using the tenant-specific context. When using multi-tenancy, you might want to configure each tenant-specific session differently. For instance, each tenant could specify different time zone configuration. The register connection provider method is used here to define the tenant-specific context. For our example, the tenant-specific context is held in the connection provider map and time zone tenant map. Now when building a Hibernate session, aside from passing the tenant identifier, we could also configure the session to use the tenant-specific time zone. Here the Hibernate session can be configured using tenant-specific context. So if we set the time use tenant time zone parameter to true, Hibernate will persist the timestamp properties using tenant specific time zone. As you can see in the following example, timestamp is successfully retrieved even if the current running JVM uses a different time zone. Here the tenant use tenant specific time zone. Here use tenant time zone allows you to persist a timestamp with the provided time zone. However, behind the scenes, we can see that Hibernate has saved the create_on property in the tenant specific time zone. Now we are considering session statistic methods in org.hibernate.statistics method in statistics. Get session close count, global number of sessions that got closed. The method long get session close count, the global number of sessions closed. This is in the interface statistics, which is in the package org.hibernate.stat. Now we are considering hibernate.session.events.auto in session events, fully qualified class name implementing the session event listener interface. As an example, we can consider, as an exception example, we can consider session exception class thrown when the user calls a method of a session that is in an inappropriate state for the given call. For example, the session is closed or disconnected. This class is in org.hibernate package. As an error example, we can consider this. No current session context configured. org.hibernate.implement.session factory implement.get current session. Now this is the end of my presentation. Thank you very much for watching it.